Hello everyone, welcome to session 6 of LTEC 654, Programming Games and Simulations. This week, I want to kick off by talking about the formal elements of games that were introduced by Fullerton and colleagues in the Game Design Workshop chapter that we read last week. Now, according to Fullerton, formal elements are the elements or components that form the structure of games, and without them, games are actually not games anymore. And so we really need these formal elements in order to create a game. And importantly, Fullerton introduces us to 8 different elements. And the first formal element of a game is there has to be players. Players, of course, are typically people, and they are voluntarily participating in the game. If it's not voluntary, then it's something else. It can't be considered a game anymore. The second formal element is very important, and that is the objective. In other words, the goals of the game. Now, we'll learn more about this, but objectives in games can break down into primary, secondary, and even player-driven objectives. The primary objective is usually considered the main objective of the game. So if you take chess as an example, the primary objective in chess is to checkmate your opponent's king. And when that happens, the game is immediately over. A secondary objective might be something like trying to defeat an opponent within a certain number of moves or within a certain amount of time. Those are related to player-driven objectives, which is really self-created goals that players bring to a game. For example, I might want to win playing chess against my opponent 10 times in a row. That is an additional player-driven objective beyond the primary objective of the game. Another important formal element are the procedures, and procedures are the actions players can take to achieve objectives. And of course, all games kind of limit what players can do, what procedures or actions players are allowed to do. And of course, the rules help define these procedures. That brings us to the fourth formal element, which are rules, and this defines what's allowable and what's not allowable within the game. In other words, it sets limits on what players are allowed to do or what actions they are allowed to take. The fifth category is resources, and these are objects of value within the game, and they are often defined by the rules of the game. Examples of resources can include lives or health. It might be time or extra time, currency, or even ammunition. Those are all examples of resources or objects of value within the game. Another formal element is conflict, and conflict stems from this idea that the path to the primary objective, let's say checkmating your opponent in chess, there has to be hindrances to that objective. It shouldn't be something that you can complete unencumbered, and it shouldn't be just a straight path. So conflict is a very important element in games, and conflict can come from the game world itself or the game system, as well as other players, and we'll be talking more about conflict in the future. Another important formal element is this idea of boundaries. There has to be a distinction of what is the game world, and we need to be able to separate the game world from real life. And of course, this is pretty obvious, but most people are able to determine what is happening within the world of the game, within the boundaries of the game, versus what's outside of the game. But still an important element of the structure of gaming. And then finally, the last formal element is this idea of an outcome or some kind of finish state that can be achieved. And importantly, we want to have some sort of uncertainty about the outcome. For example, in chess, the uncertainty centers around which player of the 2 players is actually going to win. So that's a nice overview of the formal elements that make up the structure of games. And of course, we will be thinking about how to program and account for all of these formal elements inside of the digital games that we'll be designing later this semester. Okay, with that, I want to switch gears and focus a little bit on Godot. Now, a couple of weeks ago, we talked about this concept of the scene tree. and we focused a lot on the children of a node called body. And we focused on how the first child has an index of 0, the second child has an index of 1, and the third child has an index of 2. But you're probably wondering, well, isn't body a child of something as well? And the answer is yes. Body, in the example that we used in class, was a child of main. And the index of body, of course, is dependent on how many other children the node main has. And so really what I want to talk about now is how do we reference all of these nodes in our code? And in order to answer that question, it's very important that we understand the idea that a scene tree is really a tree of trees. Now, what do I mean by that? Well, let's take a look at the scene tree from one of my sample projects. And you can see here I've set up a table so we can walk through for each node in the scene tree. We can walk through what its index is, what class or type that node is, what the parent is of that node, as well as how many children it has. So in this example, we're seeing that the root node is main. It's our very first node, and its class is or type is node 2D, and its parent is actually the viewports. And remember, the viewport is, if you're in 2D design mode, it's that rectangle that you see, and everything that is inside of that rectangle is viewable by the player or the user of the game. Now, importantly, as we're going to see, main has 8 children. Now, its very first child is at index 0. Remember, computers start counting at 0. And it happens to be a color rectangle. And its name is header background. And because it is a child of main, the parent of header background, of course, is main. And header background doesn't have any children. Now, what's the next child of main? Well, it happens to be a label named title text. And title text has an index of 1 because it's the second child, and its parent is main. And we can take a look at the third child, header text, the fourth child, which happens to be a button. We can look at another button, remove from top, remove from bottom. Now, I want to stop here on the 7th child, which is body background. Now, I say it's the 7th child because its index value is 6. Its type is color rectangle. Its parent is main, but it has children. And how many children does it have? Well, it has 3 children. So let's look at one of those children. At position 0 of body background is another color rectangle named box 3. The parent of box 3 is body background. Now, how many children does box 3 have? Well, it has 1 child, and here it is, label 02. The index value of label 2 is 0 because it's the first child of box 3. The parent of label, therefore, is box 3, and label doesn't have any children. And then, of course, there's box 2, which also has children, but it's not expanded in this view. But importantly, I want you to realize that the index of box 2 is 1. Why? Because it is the second child of body background. Similarly, box 00 has an index of 2 because it is the third child of body background. And then finally, I have a node called body, which is the 8th child of main. So it has an index value of scene, and its type is color rectangle. So I'm pointing all of this out to you because it's important that you understand that the scene tree is actually a tree of trees. And every object in that tree has an index, and it has a parent, and it may or may not have children. So this is a very important concept. Now, let's come back to our question. Well, how do we access all of these different nodes through code? Well, let's take a look at example. What if I wanted to reference the label title text in my code? Let's say I wanted to change the text of that label. How could I do that? Well, one possible solution would be to set title text.text equal to my new title. Now notice here I have to use the $sign to tell Godot that I want to communicate with the label named title text. Another way to accomplish the same thing is to tell Godot, get the child at index 1 and set its text value to my new title. Both of these pieces of code do exactly the same thing. They're just different ways of accomplishing the same goal. A third way is to use another function called getNode, and we could tell Godot get the node named title text in quotation marks and set the text value to my new title. And again, all three of these solutions accomplish the same thing. They're changing the text property of the label named title text. However, the code that's being used to accomplish that objective is different in all three examples. Let's look at another example of communicating with body, which we know is the 8th child of main and has an index of 7. So one way I could communicate with body, for example, if I wanted to change its x position, I could say $body.position.x equals 50. Another way I could do that is say, Godot, get the child at index 7 and set the x value of its position equal to 50. And a third way I could do this is say, Godot, get the node with the string name of body and set the x value of position equal to 50. All three of those lines of code, again, accomplish the same thing. It's just different ways of accomplishing the objective. Now, let's use a slightly more complicated example. We want to communicate with box 3, which is a child of body background. And of course, body background is a child of main. So how do we communicate with that node? Well, one solution, of course, and many of you have already learned how to do this, is to use the $ and say body background / box3.scale.x. That would be one way to change the scale of box 3. Here's another example. I could say, Godot, get the child at index 6, which is body background, and then get the child of body background at index 0 and set scale.x to 2. And then, of course, a third way would be to say, get node body background. Once you have that, get a node of that body background named box 3 and set scale.x equal to 2. Again, three ways to accomplish the same goal. Now let's look at one more challenging case, which is communicating with label 2, which is 3 layers deep in our tree of trees. How would we communicate with that? Well, here are the 3 examples. I could say $ body background box 3 label 2.text equals hello. Or I could tell Godot, get child at index 6, get a child of that child at position 0, and then get another child at position 0.text and set it to hello. Or I could use the getNode function and say, get the node called body background, then get the node named box 3, then get the node label 2, and set the text value to hello. Again, all 3 of these lines of code accomplish the same thing in a different way. Okay, everyone, we're out of time for today. Have a great week, and I'll see you in Canvas.